we are talking about socioeconomic benefits today. My name is Maria Lennartsson. I'm the work package leader for the work package, having some kind of overall responsibility for external communication, and we're doing these lunch talks 4 times a year. So this one is the second one. The purpose of the Anchor project is to have this goal: let's fuel the transition towards water-wise neighborhoods. And it is trying out source separating wastewater systems to retrieve the resources from wastewater in the same manner that we do in separating solid waste. So toilet water for the purpose of collecting biogas and nutrients, grey water for the purpose that are doing we are mapping the impact of decentralized water system in urban areas, and we are closely engaging with stakeholders. And this meeting is one way of engaging with everybody who's interested in taking part of what the results are in the Anchor project. And at the end of this knowledge. And there are a number of different stakeholders in this: Vito, Dukop, Hamburgwasser, Bauhaus University, Stockholm Water, Stockholm. So we are 8 different partners in this project. And today I have the completely wrong agenda. I'm really sorry. Today we are talking about the socioeconomic perspectives. Fabi is going to talk about value. Elizabeth from Ghent is talking about how the Dukop and the city of Ghent has developed the project in New Docken, and Elizabeth from Sweden is going to talk about a socioeconomic study that we've done in Stockholm. So over to you, Fabi.
Yes, I hope that everybody can see my screen right now. Otherwise, let me know. Yes, so my name is Fabi van Berkel, and I will be doing the research in Work Package 3 on the economic analysis. I'm a public design and value researcher at KWR. Today I will explain a little bit to you my approach to the research that I will be doing. And an important part of the research is doing a value mapping exercise. And what I think is important to think about is that I want to take you on board a little bit to a different or new approach to how we think about value in general. What we see a lot in casework or in practice is that there are very many different ambitions that come together in the urban environment and the way that we are relating with the systems development. And usually we look at this from a very single issue business perspective, only focused on what is my exchange in this. And in most cases it's from a financial side. But if we want to look at these kind of urban water systems in a different way, we need to take up on a little bit more of an holistic approach, which is also the H in Anchor. So how can we actually do this? There are different developments in the literature that we see on business developments and also in sustainability developments. And it's really valuable and interesting to look at multiple value creation from a more cooperative social network perspective. So if you look at the cluster itself or the way that urban systems or systems are like connected to each other, then we can also have a different view and a different story on how we should implement these systems. So in my research, I will be focusing on this, and I'm going to try to take more of a helicopter perspective on value, and also look at the system inside their own context, because every system decision or design decision for a system can be motivated in a different way in a different context. And because we're looking at 5 different cases in 5 different national contexts and also local contexts, it's important to take the local ambitions of the governments or the people, the stakeholders involved in what they actually want to develop and what kind of impacts they also want to have with this. So as we see also with the cases in ANCHOR, for example, Helsingborg has different types of flows and in its system than Hamburg. And all these kind of integrated systems have different impacts finally. And it also depends on what the local context of the implementation of this specific technology actually is. So we want to have a look at that in its own context itself. So this is also very much related to the more nexus thinking, like these type of solutions that are being developed are related to nexus thinking in a sense that we're connecting different flows towards each other. We're using different type of researchers. We're looking at how these things can be combined and how they can also have different value for other sectors maybe. But the importance is that we also need to implement these type of systems within the urban context. So there are different ways, or we need to look at this different from both these angles if we want to say something about what kind of value do these systems in a specific context actually create. Well, this is quite a challenging way of looking at it, but I found some literature that's talking about industrial symbiosis, and this can be viewed also from 2 different angles. And this is also more related to the way that languages actually and the different types of backgrounds that are actually looking at developments like this. So from a more circular economy perspective, it is seen as more of a business model archetype that's based on sharing infrastructures and byproducts to improve resource efficiency and to create value from waste. And from a more industrial ecology perspective, it's more focused on the social technical process based on the cooperative interaction of the separate businesses. So the importance in this is that, to my thinking, every different stakeholder has a different driver or a different motivation to engage in such a development. And I think it's important and it's interesting to get those kind of thoughts and driving mechanisms out of the urban development that we are studying, or the wastewater systems that we're developing. So what you can see here is also that the integrated systems have different connections that are made, different flows, different resources that are used, different types of technological systems, and they also add value to different systems in that sense, and also to different stakeholders. But seen holistically, they're all together there. So what I'm going to do in the research is also trying to have this helicopter perspective, and this is possible because the systems have been researched quite well already. So there's enough data and material that I can base my analysis on. I'm going to try to look at the development of the entire urban developments that have been made already, and trying to look at what are the starting conditions for this, in what way are people having actual value propositions in the beginning, in what way are they actually engaging with this kind of developments, what are the motivations behind it, but also the events. Like in some situations, a subsidy came across, and that meant that they were actually able to take another step in the development process. And based on that, we can look at the outcomes of what actual values have been created then in the development. And I think it's also very relevant to learn in a later phase, like what's actually the motivations behind the designs of this system in this specific context. Like, I think if we can learn from those kind of things, then it will be valuable to also see how we can actually scale up some of these systems in a different context, under different circumstances. So I think it's very valuable to learn from this kind of things. And I found a very helpful framework that can help me do this analysis, because after that, I think we also need to change our perspectives a little bit on value dynamics, because value that is being created in these type of systems, it's not something that is very fixed. Of course, you set an ambition or a goal, but then in practice, when you're developing your system, then there's many different factors that are involved in the way that you can actually create the value. For example, if it's with residual heat exchange, if there's not another stakeholder around, then you cannot set up this heat exchange. So these kind of local factors are very much related to the way that you can actually create value from a certain extent. And this type of mapping will help us to actually define what's in there, like so if there's a specific exchange of heat or water, in what way can all the stakeholders that are actually involved with that specific exchange, what are their values that they have proposed, that they've created, which are delivered and which are captured. This way will help us to actually figure out a little bit more what the motivators and the drivers and the values of different stakeholders are, and we can reflect on the ways that they actually did decision making on implementing these technical innovations in this systems design. Like, not all of them use the food waste, for example. So why are we doing that? And also maybe in some situations it's better to use the rainwater instead of a vacuum toilet. Like, these decisions on what kind of technology are we using in which circumstances is very important to reflect upon. And I think it's also very necessary to look at this cluster perspective, to have the group of stakeholders that are actually engaging in this, to make that more explicit and more clear what kind of values are created in that. So this is what I will be doing for the next couple of years, I guess 1 or 1.5 years. And I think that all the insights that we gain from this will be very valuable to see in what way, in what conditions that we can actually implement different types of systems in the future, or scale it up, or have another step in this. And I think, for example, in Sweden, in the Recolab case, we're actually also looking at in the ways that you can scale up these events, and it's very valuable to see in what way are different types of stakeholders engaging with different drivers and values that they are actually pursuing in that. So in this way, I can indeed answer my core question: in what way does a project contribute to multiple societal objectives in the long term? And I think it's important, again, to stipulate that depending on the local context, there are different societal objectives involved. So if you talk about climate resilience, sustainability, or advancing circularity, those are many different types of objectives that can all be that these kind of systems can all have value for. So it's important to see in the context itself what different ambitions are underneath that, and then you can also make decisions on which will contribute, instead of looking at all different kinds of indicators and reflecting on, okay, how did that impact? I think this is a more interesting helicopter view of what kind of value can come out of these kind of systems. And I think that was my talk. I think questions will be
later. Thank you, Fabi. We will try to collect questions towards the end of the 4 presentations, or the 3 presentations. So I will leave to Elizabeth and Dries to explain the example of Ghent.
presentation. Presentation mode, yes. No. Yes. Okay, I'm not on the first slide. So, hi, I will try to tell you in the next 8 minutes or so about the Nieuwe Dokken project in Ghent. The first steps were taken by the city of Ghent itself by drafting a spatial development plan in 2011, in which we converted an old industrial harbor area into a residential neighborhood with public green spaces. Yeah, so the general layout is here, and the Nieuwe Dokken is this part here on the right to the east of the water. I don't know if you see my mouse indicator. So those 3 red areas are the residential areas, and here are the green spaces. There was a soil pollution on the terrain which needed remediation, but that was also an opportunity to achieve a better situation environmentally. A brownfield agreement was made as a framework for cooperation between the public stakeholders involved, not only the city of Ghent, but also the regional roads authority, the water management authority, and so on. A very important point for this project was that we as a city of Ghent, or the city development company, were the owner of the terrain. And the people living nearby got to know the site by some temporary local initiatives on the site. Then it was decided that we wanted a private partner for the redevelopment of the site. So the city development company did a 2-step procedure in which there was first a selection and then the real tender documents were sent. So at first we had some 13 candidates, then it was narrowed down to 3. In the tender, of course, there was the financial criterion, but also quality criteria in which sustainability played quite an important role. Eventually, a public-private partnership agreement was signed in 2014, and the project is now partly in use, partly still being built. In the sustainability criteria, we used an instrument called the sustainability meter. We developed it ourselves at the city of Ghent because we felt that BREEAM and LEED and those similar instruments were not optimally adapted to the Belgian or Ghentian situation. For those of you who don't know those instruments, just in a nutshell, it's a long list of criteria on different aspects of sustainability. Those themes may have different weights. You see those in the diagram at the right of the slide. So those criteria offer an objective as possible approach of sustainability, going one step further than regulations, and with a focus on the results, for example, CO2 reduction, but not on specific solutions to achieve those results. Unlike BREEAM, our sustainability meter has no official certificate. Meanwhile, our instrument has been taken over by the Flemish government, who has made an update and an improved version. So what did we do specifically for the Nieuwe Dokken? We first did our homework at the city of Ghent. We made an analysis of the site qualities of previous decisions influencing the sites, and we saw that some criteria were already fulfilled, and on the other hand, some could not be fulfilled. We decided that an overall score of at least 70% should be achieved by the private partner, preferably 80%, so we wrote that into the tender. We also added some extra requirements on energy performance. The background to that is that at the time we were drafting our first climate plan as a city of Ghent. So energy was quite in the center of the focus at the time. We did not include extra requirements on wastewater or on water in general, not beyond the principal level. I think today that would be different. We also had some quick scan analysis made on heat pumps and on energy from wastewater based on some exemplary projects in the Netherlands, for example. And we added those documents to the tender just as an inspiration. We got lucky and had 3 ambitious candidates in the tender. Eventually we chose one with a very high score on the sustainability meter, exceeding our expectations. And this candidate offered the Zawend concept you certainly know, based on energy from wastewater. We fixed this concept and the very high score into the public-private partnership agreements. Since then, we follow up every year on the sustainability meter. We discuss whether this score can still be achieved. Many times there is need for discussion on the interpretation of some criteria and so on. We've had quite some efforts to fit Zawend into all necessary regulations and permits, as this is really a non-standard system in many ways. But in the end, it's working now. Just to finish, some lessons learned. I think very important in this project was the public ownership of the terrain, which really allowed us as a city of Ghent to write requirements or ambitions into the tender, whereas in purely private project you can't do that. The sustainability meter is being used in just a few quite large projects, like the Nieuwe Dokken. We feel that it's less useful in smaller projects. It's just too much of a workload, and there are less degrees of freedom. It's just better to include some specific sustainability criteria in the tender. We are fine with the sustainability meter having no certification. It's just a very good base for discussion on sustainability. A complex factor we noticed is the long duration of those projects. The criteria in the sustainability meter are fixed, but regulations change, insights change, stakeholders change, and many times it's necessary to find a balance between holding on to the key ambitions versus a flexible interpretation of criteria. Also on innovation, a balance has to be found, and I don't feel that we have found the ideal balance yet. On the one hand, we want to encourage innovation. On the other hand, we want to ensure long-term qualities, and certain city departments really look at trusted solutions, so not innovative solutions to achieve that. So that's an ongoing process to find that balance. So that was it. I've added my email address in case you have questions after the meeting. Thank you.
Thank you, Elizabeth, for a very interesting presentation. And now we'll hear from Dries, who is representing the company that won the competition. The place is yours, Dries.
Okay, yes. I tried to activate my microphone. Thank you. Thanks a lot for the very nice presentation, Elizabeth. I'm Dries Rentjens. I'm working for Ducoop. We are the private actor like corporation, which is responsible for managing the local sustainability service on the project of the Nieuwe Dokken. What is important to say is that we are not alone. Of course, Ducoop is providing sustainability services, but the real estate developer and all the parties involved in this whole process are also co-developing the site. So at this moment I speak in the name of Ducoop. Some reflections on I think what the city of Ghent created here with the sustainability meter as a tool for real estate development was very useful. I think it's required us to think in a very holistic way about the project and to see where can we use coupling chances within the project and also outside of the boundaries of the projects. This has been exemplified by our collaboration with the soap factory of Christijns. And I think this tool, now that it's also translated by and adapted by the Flemish government, is very useful for also future large-scale real estate developments in Flanders to really form a good basis of how to develop local energy and water communities that have improved resilience and sustainability, which can improve long-term sustainability and especially benefits and goals of local cities and municipalities. The second thing I think which was very important is that the city of Ghent created a place and also support this initiative and innovation within the city's boundaries. On one hand, by looking far in the future and looking for a solution that is future-proof, but more importantly, by providing all the legal framework and support to make sure that this innovative pathway could be followed and that the agreements could be made between Ducoop and the city of Ghent, ensuring us the business rights to do what we are doing today. And I think that is very important that from early on, this is supported from the city of Ghent, by the city of Ghent, to really have this in place, to have this anchor in place to ensure long-term exploitation and servicing of the inhabitants that are living there. Two reflections of what we encountered, and I think that is also what Elizabeth was saying, is that these are projects which are not being built in a day, and of course most of the time hundreds of units. Sometimes it also comes with delays, and from a perspective of a private investor, this is sometimes difficult because you cannot always foresee the delays, and these delays impact obviously the business case because you're planning your investments and you're counting on treating water and delivering energy to the inhabitants. And when this is delayed for a longer term, this obviously impacts the business case. This can be countered by looking into solutions of design, of modular design of the infrastructure, but it's not only can be solved by that. So I think it's very important if it's desired to organize these local energy and water communities on the long term, that there is also been looking at how to finance this in a sustainable way. The more because some of the benefits that are created by the project on a project level are not always coming back to the project. I give the example of, for example, imagine that a new district requires an expansion of a sewage treatment plant or a big new sewer pipe that has to be built. If you would then choose for decentralized water treatment, these cost savings will not always come on the balance of the local project. So I think it's also interesting to look into how to look into financing these projects, that the benefits that are created by the project, the multiple value benefits, where Fabi was talking about, that they in some way can also come back to the project level. So these are my reflections. If there are any questions, I'm happy to answer them later.
Okay, thank you. Before we go into the questions, Elizabeth will present a study that we made here in Stockholm. So the floor is yours, Elizabeth.
Thank you so much. Can you see the screen? I think. Yeah, I'm one reflection back to Dries and the other Elizabeth. Maybe not everyone in the audience knows how the new Docken looks like. So maybe you could after I'm done, you could show quickly what it looks like, because it's so nice. Anyways, as Maria said, my name is Elisabeth Kvarnström, and I'm going to present the cost-benefit analysis for different wastewater systems in a new urban area in Stockholm. And it's not me who did this job. It was two very competent economists, Åsa Sotekulva-Svanberg and Henrik Nordskjell, who made this study. Neither of them, unfortunately, could participate today, so you will have to put up with me instead. And the presentation here is based on a report. So this is available, and I provided the link afterwards. Just a few words about what a cost-benefit analysis is. I'm not an economist myself, so sorry for explaining this and not knowing exactly what I'm doing. Anyways, it's a decision support tool to evaluate different, for example, different infrastructure investments, and to kind of look at what kind of benefits will this infrastructure investment provide to society in comparison to their costs. So what these very clever economists do is they use different methods to monetize services that don't have a market value normally. And they, for example, they can use a willingness to pay studies to look into what is clean bathing water worth, or like impact on health from poor bathing water and such things. So they use that to put monetary values on benefits. And when they compare, are the benefits of this particular infrastructure investment higher than the cost, then it's cost beneficial to do this investment. And how much of the costs are actually covered by the benefits, that's another measure. So what Åsa and Henrik did, they looked at the study area Loudden, which is part of the Stockholm Royal Seaport area. Stockholm Royal Seaport is the largest city development project in Stockholm, and therefore I assume in all of Sweden. It has a very high environmental and sustainability profile, so there are many different interesting things happening in this particular city development. What you can see on the picture here is Loudden, which is the study area the economists look at. It's a port and industrial area today, and it's undergoing redevelopment the coming 20 years approximately. And when the redevelopment is finished, there's going to be like 10,000 people living and working there. And there's going to be offices, obviously, for workspaces, and schools and preschools and such. So what they did, the economists, they actually looked at different wastewater management options for the future Loudden when it's fully developed. And what one does in a cost-benefit analysis, you take the reference option and you look at the benefits and the costs for the reference option, and then you compare it to different alternatives. And in this case, the economists looked at 3 different wastewater systems, and I'm going to explain them in a little while. But this is essentially what the cost-benefit analysis is. You have a reference option, and you have different alternatives, and you look at the benefits and costs of each, and then you compare them with each other. A few words on the systems. Here is first our reference alternative, and it's the reference alternative is the existing wastewater treatment plant in Stockholm in 2020. And for international audience, it's an advanced wastewater treatment plant with tertiary wastewater treatment, removing nitrogen and phosphorus. The biogas produced from sludge is used for public transport in Stockholm. Sludge is reused to a relatively large degree, which means that we have a quite good recycling of phosphorus to farmland. So it's a very good wastewater treatment plant to begin with, the Henriksdal wastewater treatment plant. And this is a reference alternative. And this is important to remember. The costs for the reference alternative are based on 869,000 PE, which is the connected PE today. And then when we're looking at the costs for Loudden for the reference alternative, those costs are downscaled to 9,800 PE, which means that the costs for the reference alternative are benefiting from the economies of scale from about 900,000 down to 10,000. So it's important to remember. WS1 is the first kind of future alternative where they were comparing with, and that is like the reference option, but with the addition of membrane bioreactors to both reduce the nitrogen and phosphorus in the effluent, but also to increase the capacity of the wastewater treatment plant. So this redevelopment is ongoing right now in Stockholm. So this is like happening as we speak, basically. And once again, the costs for WS1 are based on 1.15 million PE, and then the costs for Loudden, the cost for this big number is downscaled to the smaller number for Loudden. So once again, the costs for WS1 are benefiting from economies of scale. WS2 is like WS1 with a membrane reactor, and then we imagined a future wastewater treatment plant, Rolls-Royce, you could say, where we add micropollutant treatment and we add sludge treatment and reject water treatment, so we can produce from this treatment plant a cleaner nitrogen and cleaner phosphorus for further processing. And in this case, there is no such treatment plant in Sweden, so we couldn't base the costs on actual costs, but still, it was still based on 1.515 million people, whatever costs were available, and then downscaled to 9,800 people. So all of these, WS1 and WS2, are based on innovation and development in end of pipe at the wastewater treatment plant. And WS3 is a completely different system. It's a source separating wastewater system with micropollutant removal and nitrogen and phosphorus recovery, where the different fractions, the grey water, is collected separately and treated separately all the way for water recycling, and the black water and the food waste in this case is collected separately for struvite precipitation and ammonium stripping as well. So you get the clean NMP products out. So this is a completely different system. And in this case, the figures for the system were based on the existing recovery lab in Helsingborg, Rekolab, which is a part of the bigger wastewater treatment plant there. And it's designed for 2,000 PE. So in this case, costs for 2,000 PE were upscaled to 9,800 PE for Loudden, which means that we have the opposite here. It's not an economy of scale. It's the opposite. It's suffering from lack of economy of scale. Anyways, I do realize that it's quite hard to read this picture, and I don't want you to. It's more like a visual image of the results. And what you can see here, the darker green are monetized benefits. The lighter green are non-monetized benefits. And the round one is one negative external effect. It's actually that way that WS1, you remember the existing Henriksdal wastewater treatment plant with putting in membrane bioreactors actually releases more greenhouse gas than the reference option. So that's why it's red here in the middle. And then in this way you can add and you can get minimum benefits because some benefits aren't monetized. And for WS1, there's a minimum benefit of 0.5 to 0.6 million Swedish krona per year. So there's definitely a benefit. There's a higher benefit to WS2, the wastewater treatment plant Rolls-Royce, about 1.6 to 1.8 million Swedish krona per year. And then for WS3, we have the absolutely highest benefit of 10.4 to 10.7 million krona per year. So the source separating alternative WS3 definitely has the highest minimum benefit. And here we're looking closer at the monetized benefits. And as you can see, the highest monetized benefit for WS3 is actually better sanitization. And this is related to that if you keep the blackwater on land, you actually release less pathogens, and therefore you have less incidents of wastewater related diseases. Second largest is that the WS3 is actually provides more reduction of emissions to recipient than the other ones. The third one is greenhouse gas emissions, that it's decreased with between 1 and 3 million Swedish krona per year. And the fourth one here is water recycling. Then we have the costs, and same logic here, darker red monetized costs, lighter red non-monetized. And then these costs are estimated costs above the reference option. So the reference option has a cost, and then that cost has been subtracted from these alternatives. That's how you present it. And the source separating alternative is the absolutely most expensive. WS1 costs above the reference option, 0.71 million krona per year. The WS2, 2.44 million krona per year. And the WS3, 12.2 million kronor per year, more costly than the reference option. However, you need to remember what I said in the beginning. Costs for WS1 are based on costs for about 1 million PE, and costs for WS3 are based on costs for 2,000 PE. So there's this economy of scale that plays positively for WS1 and WS2. And something to think about as well is that we did this study, or they did this study in 2021, something like that. And since I said in the beginning, WS1 is actually under construction now, the costs for these membrane bioreactors have gone through the roof a bit. So this would look a bit different if we were to do this study today. And costs for WS2 are uncertain because we don't have an existing treatment plan to base the costs on. So let's jump into the summary of the results. Remember what I said? Benefits minus costs should be a positive value for an investment to be beneficial, like cost beneficial to society. And the benefits to cost ratio should be above 1. And as you can see here, neither of these options actually fulfill these requirements. However, the option that covers most costs is WS3, the source separating. It covers 85% of its costs, whereas for WS1 it's 70% and WS2 is 66% of the costs. And please remember, we have uncertainties in the cost estimates. We also have uncertainties in the benefits estimates. And there are also benefits that aren't monetized. But anyways, the conclusion from the economists that did this study is actually that innovative systems like source separating wastewater systems can actually, because they provide so many more benefits to society, they can actually compete with end-of-pipe, more conventional investments from an economic perspective, in spite of higher investment costs. And thank you. And here's a link to the report and email to one who can answer questions more in detail, and also my email.
Thank you, Elizabeth. There are a few questions, or one question from the audience. We have now about 10 minutes to discuss a bit more. There's one question from Lucia to Fabi. Hi, thanks for the presentation. How do you define the social objectives and measures measure the contributions towards them?
Yes, well, Lucia, thank you for your question. This is a very good question, of course. The angle that I chose to study the topic of value mapping is that I wanna engage with the local context. So I'm not gonna propose or define specific societal objectives that need to be surrounded around these systems, because we're studying 5 different cases, and every local and national context have different ambitions on how they're approaching climate mitigation goals or climate adaptation goals, etc. There's also different challenges involved in these different national contexts. So my point is that I'm not, as a researcher, going to impose my definitions on that. So I think it's important to look at it from the bottom up and see what's actually been, what are the objectives of the local setting. And based on that, I'm going to review in what sense did this system contribute to that. So this is actually also related to what was being said by the Ghent municipality, Elizabeth. She also said that they have the sustainability meter, for example. They have measured already what kind of impacts they are made. But she also said that these ambitions are changing and that the stakeholders also are changing in this development. So I think it's important to have more of a focus on how these dynamics and how these relations are working, then that I will define exactly in what way these things are measured. I think in the end of the research, we can maybe assess to what extent different local contexts are doing this, but I don't think it's valuable to actually focus on evaluating that sense in general. I think the second question is also indeed related to that. So how I mentioned indeed contribution to societal objectives in long term. I think this question also relates to in what way local developers are actually defining that for themselves. Like I know, for example, in the Netherlands that we talk about operational phase in 0 to 2 years, developments of longer term or like midterm or more tactical term are 0 to 5 years, and some strategic projects can be 10 to 15 or 20 years or even longer. And if you talk about the development of infrastructure, sometimes different systems, they will be there for 50 years. So if you want to look at value capturing, you can also decide if you want to maybe extrapolate in terms of like social cost benefit analysis, which is a proper tool to do this thing. It depends on how you are going to look at it. So this is something that I will discuss in the cases. In what way are we actually looking at the time frame of what values will be created? For a really small specific example is when you are implementing trees that will have a very good benefits for climate adaptation, because it will help you minimize heat stress. It costs space inside of your urban environment, but the benefits will only come out after maybe 10 years because this tree needs to grow. And there's a difference in how you are relating to very short-term return of investments in that sense, and these type of environmental return of investment. So the time frame depends on the way that you look at that.
Okay, thank you. There are questions coming in here. Brightwater Tools are asking, this presentation is so valuable. Is Anchor Project ready to share the link to these recordings? Yes, we will. We will send out the recordings and the presentations to the people that have been participating in the meeting. There's one more question from Fabi, but maybe we should start with a question to Elizabeth. Did you reflect on whether the increase from 2,000 to 9,000 PE for the water system led to economic? Maybe you can read it yourself. And it's
yes, whether it was economies of scale for that. It's actually the opposite. If you go from a small system and you upscale it, you don't get the economies of scale. That's what I was trying to say, that for the systems going from 1 million people down to 9,800, the 9,800 system gets to benefit from the economies of scale from 1 million people. Whereas in the case of the source separating system, it was the opposite. So the costs were based on the costs for this pilot and the first in Sweden source separating wastewater system in Helsingborg for 2000 PE, and then the costs for that were upscaled to 9,800 PE. So the opposite. So costs which are definitely higher for smaller systems were carried on to a larger system of 9,800 people. And I think that's one of the reasons that the economists said that, you know, okay, it doesn't look that these systems actually do have a lot to contribute with. And they also say in the report that the costs, of course, will go down with time for these innovative systems. When we have larger systems, we have learned more, and so on and so forth.
Okay, and then we have Mikey sending a question for Fabi. You mentioned contribution to societal objectives long term. What does long term mean? How many years?
I think I already answered that question.
Okay.
I followed up on the previous question.
Okay, and then there are two questions for Elizabeth Kvarnström. This one regarding technology. Do you think if Stockholm, they will keep blackwater and food waste separate and thus have two digesters instead of one? Would that also affect the cost, I guess?
Yeah, maybe you want to answer that, Maria.
Yeah, I mean, it is based on the Helsingborg case, and they already have two digesters. So it is three different treatment lines that we have added in this cost benefit analysis. And then there is another question for Elizabeth. You mentioned that in work in BS3, experiences from Helsingborg were used as reference. What is the name of the project in Helsingborg?
Yeah, it's H plus and Recolab. H plus is the city development, the larger area in Helsingborg, and the recovery venue is called Recolab. Yes, and there's definitely a lot going on there. So, and you will learn more if you follow the ANCHOR project, because a lot of information from Helsingborg and New Docken and the other sites are published through ANCHOR.
Yeah, there's one more question regarding this economies of scale, but I would like to pose a question for Elizabeth and please from Ghent. I think it's very interesting that you have the sustainability criteria of 20%. You mentioned that you did not include wastewater as such in those sustainability criteria, but how come that the project in New Docken actually got as high score as 93%? What was the main reason for that?
Different reasons. As I told, the sustainability meter contains different aspects of sustainability. It's on energy, it's urbanism, mobility, water, green spaces. So, in fact, on all these aspects of sustainability, the candidate made very sustainable choices. And I suppose there are some criteria referring to wastewater, but that would only be a small percentage. So I think this choice for the Zalent system, it in fact only has a small influence on the score in the sustainability meter, but it's the overall sustainability concept that was in all respects very, very good.
And this, from your side, what was the main reason for getting into that innovation process? Short, I need to just close and tell what the next meeting is going to be.
Sorry, I didn't understand the question.
Yeah, I was asking Dries what the reason was that they jumped on this competition.
Yeah, I think there were certain opportunities that we saw from on one hand we did a some studies about the potential of the waste heat, what was present from the soap factory of Christijns, and we saw that it was not sufficient to provide a whole district of heat. So we had to look for a complementary heat source, and in that aspect, heat recovery from wastewater came into the picture. And Peter, one of the founders of Ducoop, already had experience with recovering heat from wastewater in another project he did in the city of Leuven in Belgium for a social housing project. So these things, they came together. And after a visit in the Netherlands, in Sneek, they decided to push the ambition even higher by going for full source separation with vacuum toilets in the whole concept. Yeah.
Okay, thank you. Just a quick presentation, quick reminder that our next lunch talk will be on the 23rd of September. And the topic for the next meeting will be blackwater. How can we collect and treat it? And what are the resources that we want to recycle from blackwater? And it will be experiences from the different projects in ANCHOR. So thank you very much for participating, and please follow us both on LinkedIn and on the web. And see you next time.